Hey guys, what's up? So today we're going to be looking at the universal set, all right? And it says for any particular problem, the universal set is the set from which all the elements are taken. Let me just repeat that. It's the set from which all the elements are taken, okay? It's very simple, guys. So basically, the universal set is the set in which all the elements are in. Every possible element is in for that set, all right? And it says the universal set is denoted by the symbol U. And there's an example here. If A is equal to X such that X is greater than 0 and X is an element, this is actually should be an element of Z, which is the integer set, right? Then the universal set is a set of natural numbers N, okay? And that makes sense. Let's look at this. Remember, integers are positive numbers, right? Meaning 1, 2, 3, 4, 5, 0, and negative numbers, right? Negative 1, negative 2, negative 3, and so on, right? So if x is greater than 0, right? That means that x is 1, 2, 3, and x is an integer. That means that the universal set is just the set of natural numbers, right? Which is the counting numbers, which is 1, 2, 3, 4, 5, 6, and so on. All right, so the universal set for this setting example is the natural number set, okay? Because it's the numbers that are greater than 0 and they have to be integers, which is 1, 2, 3, 4, 5, 6, and the normal set of counting numbers. All right. Okay, so let's just clear that for the moment and let's look at this example down here, right? This example says, okay, so you have the universal set here, U, and this is how we draw it in a Venn diagram, guys. So this square is the set of all the numbers, and then we have a set A here, right, which just has 1 and 2 in it, right? So when we look here, we can see that A is just a set of 1 and 2, and the universal set U, you notice it's written on the top of the Venn diagram, right? The universal set U is 1, 2, 3, and 4, okay? All right, so this is a pretty good example of what the universal set is going to look like. And we have a nice little U there, which represents the entire set for all the numbers. And it's the set from which all the elements are taken, in this case, 1, 2, 3, and 4. All right. All right, guys, so let's move on and look at some more definitions until we get to more detailed examples about Venn diagrams and universal sets. All right. All right, guys, so we're looking at subsets now, and it says if A and B are any two sets and all the elements of A are contained in B, then we say that A is a subset of B, right? Which means the same thing here. A is a subset of B, right? And this symbol here, which looks like a long mouse C, means a subset of, right? And this here with the cross through the long mouse C means not a subset of, all right? All right, so let's look at this example here. And this example says A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5, and C is equal to 9, 10, 11, right? We can clearly see here that A is actually a subset of B, right? Because 1, 2, and 3 are actually in B, okay? So A is a subset of B. We can also see that A is not a subset of C because 1, 2, and 3 are not in C. And we can also see that B is not a subset of C, right? Because 1, 2, 3, 4, and 5 are not in C, right? So, right, this just gives a perfect example of what a subset is, okay? Let me give you another example here. Suppose we had D is equal to 1 and 2, right? We could actually say that D is a subset of A, right? Let me write that better. Right, we could actually say that D is a subset of A, right? Because 1 and 2 are in A, and D is also a subset of B, right? Because 1 and 2 are also in B. Cool. But A is not a subset of D because D does not have 3 in it. So 1, 2, and 3 are not in D. Okay. All right, guys. So this is pretty much a good example for this. I don't think we need to elaborate any further. But we're going to show you how you can break up every subset possible from a subset. All right, after this example, we're going to look at it right now. Okay. All right, guys. So we're looking at the number of subsets now, and it says if B is equal to A, B, and C, then the subsets of B are. So I left some space to write them out here. Okay, and the first two sets I'm going to write are the empty set and the set itself, A, B, and C. Okay. And if you look down here, it says the empty set is a subset of all sets, and every set is a subset of itself. So these are 1 and 2. Okay, these are the first two subsets of the set. And the next one, it's gonna be just A alone, right? A alone should be a subset of this, A, B, and C. So should B alone, right? And so should C alone. Okay, so that gives us 1, 2, 3, 4, 5 subsets. Then the next one would just be A and B by itself, right? Then the next one would be A and C by itself. And then the next one would be B and C by itself, all right? And yeah, and that would be 6, 7, 8 subsets of this set A, B, and C, okay? And it doesn't matter what the order is, guys. So CB is the same thing as BC, right? So that's why we're not writing them in any other order, because it really doesn't make a difference, all right? All right, and it says the empty set is a subset, right, which is this one, and every set is a subset of itself, right? So this is this one, and we have these 6 other subsets here, and it says there is a specific formula for the number of subsets a set should have, and it says S, which is the number of subsets, is equal to 2 to the n, where S is the number of subsets and n is the number of elements. So in this case, guys, let's use the formula to see if we have the right number of subsets. S is equal to 2 to the 3, right? And 2 to the 3 is actually equal to 8. And we do have 8 subsets here. So this is definitely correct. All right, guys? All right, so we're going to do some examples of these. And you can look into it. Really try to practice and write out all the subsets in the examples. All right, guys? But we're going to move on to another definition now. All right? Hey guys, so we're going to be looking at equal sets, and it says two sets A and B are said to be equal if they both have the same elements. Okay, you have to have the same exact elements. So the example here says A is equal to 976 and B is equal to 679, right? Now this says here A is equal to B, which is equal to 6, 7, and 9. Okay, and it says the order in which the elements are written doesn't matter, right? It does not matter. So if you have two sets, 1, 2, and 3 here, if you write them in the opposite direction, meaning you write 3, 2, and 1, they're still equal. These sets are still equal to each other. Okay, so sets are only equal when they have the same number of elements and it's written with an equal sign. A is equal to B. All right, guys. Cool. All right, this is pretty simple. I don't think this could get any simpler. All right. So let's look at another definition now. Okay, guys. All right, guys. So that's it. And I'll see you in the next lecture. And remember to do your best and God will do the rest.